Hello, welcome to the first video in a playlist about physics engines. Now, strangely enough, this video that I'm making right now, that you are watching, because somehow you are, is made in 2017. But the next videos that follow in this playlist were made several years ago, and those videos cover two specific physics engines, Box2D and toxiclibs. So what I want to do in this video is kind of make a little update to what's the state of physics engines today, what are physics engines, what are some example physics engines that you might be interested in, what are some of the features of them, how do they work, and then if you keep being interested, you can continue and watch some of the more specific tutorials. At the very end of this playlist, you'll find some new updated physics engine tutorials with some newer physics engines that I've only started recently looking at, most notably a JavaScript one that runs in the browser called matter.js. This is an example of a processing sketch, a computer program, drawing graphics to the screen and using a physics engine behind the scenes to figure out when do things collide, what should they do after they collide, all of the motion and animation, the location, position, velocity, angle, all of the stuff that's telling me what to draw in this canvas is in the physics engine. That makes no sense whatsoever. Let me try to make this make sense. Okay, so if you've watched any of my previous tutorial videos, one of the many programming tutorials, this is a thing that I do. I have a variable, let's say I'm writing code in JavaScript. I have a variable called x, maybe. And then somewhere in an animation loop, like the draw function in P5.js, I might say something like x equals x plus 1. And what that gives you is, if I want to draw something at that particular x location, maybe at a y location of 100, if I increment its location every frame, it's going to start to move. This, in a way, is a physics engine. What's the world of physics? It's a very simplistic world. Things can only move at a constant velocity on one dimension by 1 unit every moment of time. But ultimately, this is a physics engine. Now, if you followed some of my other tutorials, I start to add in a lot more things, like a y, and maybe I start using a concept called a vector, whether it's a p vector in processing or a p5 dot vector. And then I'll start to have things like, oh, there's a position, and there's a velocity, and there's an acceleration, and there's a force. And so, and then acceleration goes into velocity, and velocity goes into position. All of this kind of stuff to formalize and encode a framework, a system for how things move around a computer screen, modeled off of the way things generally pretty much move in the real world. You know, lots of scientific caveats aside. So this is the trajectory that you'll find if you go back and watch a lot of my Nature of Code video tutorials, or even a lot of the coding challenges where I'm moving and animating things in a computer graphics window. Now, what if someday, you know, this will get me pretty far and is actually a really nice way to work because I have total control to invent my own creative take on physics and different kind of behaviors and make creatures that have thoughts and desires and all sorts of things. It leads you to do a lot of exciting, interesting things. But there are moments where you might think to yourself, ugh, all of this vector math and I got to do collision and suddenly, you know, I want to know what happens when this strange polygon collides with this circle and does it bounce off this way? You know, you start to go down this road and suddenly you're, you know, spending years of your life developing these very elaborate, sophisticated algorithms to figure out how to make things move based on physics. And these are not new problems. And so there are libraries, frameworks that you can import into your code to eliminate the need for you to write the lines of code where you add velocity to position or add acceleration to velocity. And all you do, the way that a physics engine generally works, is you can think of this as the physics engine. It's a box, and in some ways it's a black box. You don't have to know how it works inside to make use of it, although that, you know, it's kind of hard to just use one without some of this basic sensibility and having done some of this yourself to understand about forces and vectors and all that kind of things, because these concepts are all embedded in physics engine. But if you have this black box, you have a moment writing in your program, like the camera's over here, but I'm over here, can you see me? There's a moment where you have your program starts and you say, hey, world of the thing that I'm making, I would like you to have some circles floating at the top of the screen. And then maybe a rectangle at the bottom. And then you should have this little like spinning wheel. And then I'm just going to say go. So the idea with a physics engine is that you have this kind of setup where you tell the world what should be in it. So in setup, you might say, here's what I imagine the world to be. It starts with, and one of the coding challenges I hope to do that'll be in a future video is Plinko. So I want to have, a bunch of static knobs in the window, and then I want to have a thing that's at the top, and then I want to have some buckets at the bottom. This is such a weird example, okay? So it's all about, in setup, is saying, here's what's going to be in the world. Then you tell the physics engine, here's all the things, here's where they are, here are their sizes, and then you say go. And then there's this animation loop, the draw loop in processing or P5, every moment in time. And what you do every moment in time is you say, oh, physics engine, where is the stuff? So you set up where all the things are, all of the things of like moving the stuff around, checking if it's colliding, and then if it's colliding and velocity changes this, all of that is done inside of this so-called black box, the physics engine, and your only job is to say, where is everything? Now I would like to draw it. So this is the paradigm that you'll find in physics engine after physics engine. And there's a bunch that I want to discuss and talk about. So let me make a list of different physics engines. We can talk about some of their features. So Box2D being one of the more famous well-known physics engines that's behind a lot of well-known games like sort of 2D mobile games like Angry Birds, fill in all the other ones after that. Box2D. There's a physics engine, and actually something called toxiclibs, which is processing. What started specifically for processing, a Java library, and it's actually a much broader library beyond physics. But one of its components is a simple physics engine. What else? There is something called a Bullet, which is a physics engine specifically for 3D. There is a physics engine that I want to look at called matter.js. Canon.js is another one that I recently found, and the list goes on. So I'm sure I'm missing, your favorite physics engine or a really good one, or one that's really useful in this particular context or for this particular programming language. But this is a list of ones that I know something about or that I find useful in some context whatsoever. So one thing that you might consider, or you over there, are you watching? Did you run away? I would totally understand. One thing that you might consider is whether you can do this in 2D or 3D. So Box2D is, you might have noted by the name, is 2D only. 2D. Toxiclibs has both 2D and 3D physics. Bullet is a 3D physics engine. Matter.js is 2D. And canon.js is 3D. So I don't know why they all get an exclamation point, but they're very excited about their number of dimensions. I am a 2D physics engine. Another thing that you might think about with physics engines is what features do they have? So, what language, is it 2D or 3D? But really the key thing is features. And actually I realized that this list is kind of useless. I'll leave it there because what I want to just take a moment to talk about is, well, I missed a kind of key piece here, which is, if I need to tell the world what kinds of things are in it, well, how do I do that? So what are the kinds of elements that go into the world? So almost all of these physics engines use the same paradigm, which is, and I'm going to use, each physics engine might use a slightly different term for the same thing. But for all these physics engines, there's generally something called a world. So the world is the thing that the world is the entire world of what the sort of space, the physical space, whether it's 2D or 3D, that the entities that you're going to place into that world live in. And it could have, it could have kind of global properties, like it could have a global gravity. It could have boundaries, where things can't go outside of. So typically, most of these physics engines have a world. The other thing these physics engines have typically is something called a body. A body being an entity that goes into that world. And it might be a circular body, a rectangular body, an arbitrary polygon type of body. And I'm kind of conflating something though, which is Box2D in particular has two concepts, which is a body and then a shape. So the body meaning the sort of singular empty point that's floating, that's moving around through the space, and a shape being actual physical geometry that's attached to it. So we could think sort of, but some of the physics engines that are a little less sophisticated are just, it's sort of the same thing, that body and shape are the same thing. So body and shape. The other thing that most of these physics engines have is something, I'm trying to think of which term to use. In Box2D, it's referred to as a joint. In matter.js, it's a constraint. In toxiclibs, it's a spring. And so I'm going to call it just a connection, or I'm going to call it a spring. No, let's call it a connection. And so what I mean by that is, what if you had, as your physics engine, there is a body and it's connected to another body that's swinging like a pendulum? How can you have a constraint or a spring or a joint that attaches two bodies? And it's kind of amazing what you can build just from that. Generically, if I have a way of placing any kind of shapes in the world, connecting them in some way that I want, and then saying go, experience gravity, bounce into each other, interact with the mouse, experience of force, there's a lot of worlds you can create that are quite engaging, exciting, and to play with. So, these are kind of the features, but there's a kind of key thing. I really should have started this whole video. If you're still watching, good for you, because here's the real thing. When do you want to use a physics engine, and when do you not want to use a physics engine? And it's sort of like a strange question, because no matter what, you're using a physics engine. The question I'm really asking is, when do you want to just use your own custom-baked x equals x plus 1 or position.add velocity, or your own kind of cooked-up mechanic for how things move around a space, versus just use somebody else's mechanic that you get to set up and then reap the benefits of as you draw things? And there's no answer to this question. And most of the time, you're in a sort of in-between space. But there are a couple scenarios that I think are key scenarios when using a physics engine is incredibly valuable. Key scenario number one: collisions, 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 collisions. It's like real estate, location, location, location. Physics engines, it's collisions, collisions, collisions. So if I'm ever working on a project and I'm moving stuff and I'm using steering behaviors and I add some gravity and I've got all this stuff cooked up in my code, and I realize what I really need is for these shapes as they move around to bounce off of each other. This is generally where I want to move towards using a physics engine, because rather than spend hours and hours on Stack Overflow and reading through lots of Wikipedia pages to work out all sorts of geometry, math, and collision detection and resolution, these are solved problems that are built into a lot of these physics engines. So that's kind of arbitrary thing number one. I don't know where I am on this whiteboard, which is to use collisions. Not to use it, to use a physics engine if what you need is collisions. Here's another place. So what reminded me of this is this idea of physics engines having a world, a world that's full of bodies and connections. And so one thing that physics engines are very good at is if you want to build some type of simulation that's based on a connected system. So, some examples of this are cloth simulation. Cloth simulation, how is that a connected system? Well, actually a way, and I have a coding challenge that I'll link to in here that builds a cloth simulation using the toxiclibs physics engine. But you can think of, well, what is a cloth? What if you had a lot of dots? You're going to have to watch this video for a little bit while I draw a whole bunch of dots. And then what if you connected all of those dots with some sort of springy, elastic connection, joint, spring, and then you pulled on one. And I'll show you a version of this in a minute when I show you some examples. So this is the way, and then you textured it with color or whatever, that sort of thing. So cloth, hair, these types of connected base systems. What if you wanted to make, a cute, cuddly character like this, I don't know, with some ears, and it's sort of like it's soft and it bounces and it jiggles and it wiggles around. Well, you could build this by creating a set of particles, perhaps, that are connected with springs and maybe some interior connections to keep it from collapsing on itself. And that could be the skeleton physics behind this particular character. And there are lots of examples. So the other thing that's sort of key about using physics engines is you don't have, the way you set up the world and tell the physics engine what's in it could simply be a skeleton for what you lay on top of it. You might say, hey, there's a lot of circles in this world, but what you're going to draw are, images of birds that are kind of circular. And there's a lot of rectangles in this world, but what you're going to draw are like little cardboard box textures, wood box textures, that type of thing. So collisions is a key thing, and also connected systems. So these kind of soft body simulations, cloth simulations, chain, pendulum, there's a lot of scenarios where this idea, which a physics engine is going to kind of do a lot of this stuff for you. It's a kind of known way of implementing something. Okay, so what I want to do here is, if thinking about collisions and connected systems, is I want to look at these and kind of think about what kind of features these engines have. So Box2D is like kind of amazing for collisions. So if you want to work with collisions in 2 dimensions of any arbitrary geometry, Box2D does this incredibly well. If you want to work with connected systems, springy, soft body simulations, cloth-based simulations, that type of thing, toxiclibs does this really well. Now, you can do those kind of simulations in Box2D. The toxiclibs is really just highly optimized towards this world of particles and springs. And toxiclibs has no collisions. So toxiclibs is just a particle spring-based physics engine with no geometry whatsoever. So in this sense, if you want to work with, so these are sort of features here. Bullet for 3D, I actually have really barely any experience whatsoever. I just made one example that uses a processing library for Bullet. But for 3D collisions, you can use Bullet for that. And then matter.js, really, I would say collisions and connected systems. Looking at it, there's a lot of features for both of those things. So, you kind of, I guess there's a puzzle here, which is I'm working on a project that's, I want it to be in the browser, and I want it to just be a cloth simulation. Maybe toxiclibs is all you need. Well, I'm working on a processing sketch, and I really need to have, I'm making a 2D game where all the stuff is like bouncing off of it, and it's all these like strange polygons. Well, maybe I would use Box2D. But if I'm in the browser and I kind of just want a very generic physics engine that has collisions and constraints, and then I might use matter.js. So hopefully, if you actually watch any of these videos and see some of the examples, you'll see where some of the physics engines really shine and where others maybe aren't as useful. One thing I'll say in terms of degree of difficulty, there's a level of complexity that the engine has in terms, which is, if it has a high level of complexity, that's really great in terms of possibilities, but also makes the overhead of working with it so kind of extreme that sometimes it's not worth it. If all you want is like a bouncing ball, you don't really necessarily want to go through all of the rigmarole of importing all the Box2D libraries and learning how all the pieces work, and you've got to set up all this extra code. But in terms of ease of working with, I would say Box2D is probably one of the hardest. Toxiclibs in many ways is one of the easiest, but it's a library from many years ago, and finding the documentation and examples is a bit difficult to do, whereas Box2D has such a large user base. There's a lot of documentation and examples for it, albeit, depending on what environment you're working with, there's not necessarily as much for working with it in the browser. But matter.js, one of the reasons I wanted to explore it is it has a really nice website with thorough documentation and a lot of good examples. If I come over here, you can see, so this is an example of Box2D running in processing. And one of the nice things about Box2D, it has a concept of a motor. So you can see there's actually the motor is on right now. If I click the mouse, you can see this is a revolute joint. It's actually a way of attaching two things based on like a singular point that one object can revolve around. And so you can see almost like a wheel. You can see without the motor, this kind of seesaw just responds to what's landing on it. But if I turn the motor on, it's going to turn and actually activate and start to hit these circles that are falling from the sky, so to speak. If I go to another use for, this is an example of Box2D, which has something called a chain shape, which I'm using to create this surface. And you can see here that I'm also using revolute joints. I can't remember if I made this example or not, but revolute joints to have the wheels of this car turn and move along this surface. So that's, you can see some possibilities here with Box2D. This is an example of using, these are called distance joints, which are like springs in Box2D, where all these circles are connected, creating this like springy like bridge. And if I click here, I can add rectangles to the system, and you can see they're kind of landing and getting caught on this particular bridge. So these are the kinds of things that you can think about making in a system like Box2D. Now, what else do I have to show you? So in terms of thinking about toxiclibs and connected systems, this is actually a toxiclibs simulation where it looks like, oh, I've got this like stringy rope-based thing, and I can kind of click on this and grab it and move it. But really what this is, if I were to go into the code just for a brief second and just change this to ellipse p.x, p.y, 8, 8, I'm going to draw little circles there. This is actually what's, oops. This is actually what's going on. So if I zoom in here, you can see that what this actually is, I'm not drawing the lines between them, is these are just a lot of particles, each connected by a spring. So when you pull on one, it pulls on the other. But depending on how I render it, I can render it all as a continuous line, which gives it kind of like a string-like quality to it. A string or rope-like quality to it. I can put this back, and I can display a larger circle at the bottom. And now you can sort of see more what it looks like here with this kind of view. So this is toxiclibs, and I could open up another toxiclibs example just to show you this idea of like the cloth simulation. So you can see this is a lot of particles all connected by springs, but in a grid with some gravity pulling down, and the two that are just locked and attached to the top. And you can see it has a kind of cloth-like quality to it. And then matter.js. So here's the website for matter.js, and you can see what's really nice is just right on the home page, it's showing you a lot of demos of the kinds of things you can do with matter.js. This is my favorite, these little like car things. Oh, actually that's my favorite. I love this one. I gotta build some of these as like a challenge or something. Okay, so that's a bit of an overview about Physics Engine. I'm doing this as a live stream right now. You might be watching this as an archive video. And so what I'm going to do is now take some questions from the chat to see what I missed and answer them.